the second row is 0, 5, see 2 minus 2 0, then 9 minus 4 5, then 3 minus 6 minus 3, and then minus 1 minus 10, that is minus 11. Then multiplying first row with minus 1 and add into the third row, so basically 1 minus 1 0, 0 minus 2 minus 2, then 4 minus 3, that is 1, and then 9 minus 5, that is 4. Okay, now the next process, this is first for the first row, this is our leading entry. Below that leading entry we have 0 in the particular column. Now for the second row, this is our leading entry. Below that leading entry we want to make 0 here. So we are multiplying second row with 2 by 5, right, and add into the third row. Okay, 2 by 5, we are multiplying second row with 2 by 5. So multiplying second row with 2 by 5 and add into the third row. So the first row is as it is, 1 2 3 5. The second row is 0 5 minus 3 minus 11. The third row is 0 0 minus 1 by 5 minus 2 by 5. Because of, you can see when you multiplying second row with 2 by 5, so this second row, the second element become 2 and minus 2, so this is 0, right? Correct. Now multiplying second row with 2 by 5 here, so you will get minus 6 by 5. 1 minus 6 by 5, that is 5 minus 6 by 5, correct? So minus 1 by 5, correct? So this is minus 1 by 5. And then when you multiplying second row with 2 by 5 here with minus 11, so you will get minus 22 by 5, and 4 minus 22 by 5. So when you take LCM, you will get 20 minus 22 by 5, so you will get minus 2 by 5 here. Okay, so it's just numerical that you can understand. Now this is in row echelon form matrix. This matrix in row echelon form matrix. So the given matrix is in row echelon form, hence minus C1. Now multiplying third row with 5, so you will get 0 0 minus 1 minus 2. So minus C1, that is equal to minus C3 is equal to minus 2, then 5 C2 minus 3 C3 is equal to minus 11, and then C1 plus 2 C2 plus 3 C3 is equal to 5. So C3 is equal to 2. Put the value of C3 in the second equation, you will get C2 is equal to minus 1, because see 5 C2, that is equal to minus 3 into 2 minus 6, 5 C2 minus 6, that is equal to minus 11. That means what? 5 C2 is equal to minus 11 plus 6, right? So that is minus 5. So 5 C2 is equal to minus 5, so C2 is equal to minus 1. Okay, and then put the value of C2 and C3 in this equation, you will get C1 plus 2 into minus 1, so minus 2 plus 3 into 2, 6, right? So C1 minus 2 plus 6, so plus 4. C1 plus 4 is equal to 5, so clearly C1 is equal to 5 minus 4, so that is C1 is equal to 1. So hence the coordinate vector V with respect to the given basis S is 1 minus 1 2. Okay, so next question is what is the next question? In this question, see, also find the vector with respect to the basis S in U with respect to basis S, that is equal to minus 1 3 2. So in this case we want to find the vector such that the coordinate vector is this one, minus 1 3 2. So basically we want to find minus 1 into V1 plus 3 into V2 plus 2 into V3. So using the definition of coordinate vector, we obtain V is equal to minus 1 V1 plus 3 into V2 plus 2 into V3. Put the value of V1, V2, V3, that is minus 1 into 1 to 1 plus 3 into 290 plus 2 into 334, that is equal to minus 1 minus 2 minus 1 plus 6 27 0 plus 6 6 8, and then you can see 6 plus 6 12 minus 1 11, then 27 plus 6 33 minus 2 31, and then this is minus 1 plus 8 7. So 11 31 7 is the last answer, right? Next question, here to complete the solution of this question, the next question, question 4a, let A is equal to A1 A2 A3 A4 and B is equal to B1 B2 B3 B4 be two matrices in the matrix space M, set of 2 cross 2 matrix, and let this inner product A1 B1 plus A2 B2 plus A3 B3 plus A4 B4. Show that inner product AB is an inner product, right? This inner product in set of M 2 cross 2 matrix. So to prove that this is inner product, for that we have to satisfy the 4 conditions using the definition of inner product. That means what we have to prove, inner product AB is equal to inner product BA, then inner product K into AB, that is equal to K inner product AB, right? Then this law that inner product A plus BC, that is equal to inner product AC plus inner product BC. This is inner product alpha A B, that is equal to alpha inner product AB, and the last one is inner product A with A, that is always greater or equal to 0, and if this equal to 0, that means all the numbers, all the A1 A2 A3 A4, that is equal to 0. So one by one we are proving all the 4 conditions to become inner product, and for that let C is equal to C1 C2 C3 C4 belongs to set of 2 cross 2 matrix and alpha belongs to R. First one is inner product AB, that is equal to by definition A1 B1 plus A2 B2 plus A3 B3 plus A4 B4. Now that can be expressed as B1 A1 plus B2 A2 plus B3 A3 plus B4 A4, and that is equal to inner product BA. Okay, so inner product AB is equal to inner product BA. Now next is first of all you have to find A plus B, that is A1 A2 A3 A4 plus B1 B2 B3 B4, that is equal to using addition for standard matrix, right? For addition in matrix 2 cross 2 matrix, that is equal to A1 plus B1 A2 plus B2 A3 plus B3 and A4 plus B4, right? Now inner product A plus B with C, that is equal to, by definition you can see what is our definition of inner product, that is A1 B1 plus A2 B2 plus A3 B3 plus A4 B4. That means what, the first element multiply with the first element of B, then the second element multiply with the second element of matrix B, right? Similarly with the third element and fourth element, third coordinate and fourth coordinate. So same definition apply here. We are taking inner product A plus B with C, and C is C1 C2 C3 C4, and A plus B is this matrix, right? So inner product A plus B with C, that can be expressed as A1 plus B1 into C1 plus A2 plus B2 into C2 plus A3 plus B3 into C3 plus A4 plus B4 into C4, right? That can be expressed as A1 C1 plus A2 C2 plus A3 C3 plus A4 C4 plus B1 C1 plus B2 C2 plus B3 C3 plus B4 C4, that is equal to inner product AC plus inner product BC. Okay, now alpha into A, that is equal to alpha A1 A2 A3 A4, that is equal to alpha A1 alpha A2 alpha A3 alpha A4. Now alpha inner product alpha A with B, that is equal to alpha A1 B1 plus alpha A2 B2 plus alpha A3 B3 plus alpha A4 B4. So alpha into A1 B1 plus A2 B2 plus A3 B3 plus A4 B4, that is equal to alpha into inner product AB. Okay, now the last condition, inner product A with A, that is equal to A1 square plus A2 square plus A3 square plus A4 square, because you can see the definition is what is A, inner product A with B, a1 b1 plus a2 b2 plus a3 b3 plus a4 b4. Now when we are finding inner product A with A, that is equal to what? A1 into a1 plus a2 into a2 plus a3 into a3 plus a4 into a4. So that is equal to a1 square plus a2 square plus a3 square plus a4 square, and that is always greater or equal to 0. That is always greater or equal to 0. Now next is, if inner product A with A that is equal to 0, then a1 square plus a2 square plus a3 square plus a4 square, that is equal to 0. Now square of all the real numbers, that is equal to 0. Addition of the square of all the real numbers, that is equal to 0. That means what? That all the real numbers must be equal to 0. So a1 is equal to 0, a2 is equal to 0, a3 is equal to 0, and a4 is equal to 0. Thus all the exams are satisfied for inner product AB. Hence inner product AB is an inner product in set of 2 cross 2 matrix. So here we complete the solution of this question paper up to question number 3C. Thank you.